So our eval here in tiny scheme, whoops, there we go, has a cond with 4 cases. And in the real one, when you look at the code, there'll actually be 5 cases. The last one is else error. But basically here, I'm trying to simplify things as much as possible. So we're dividing things into 4 cases. If the expression is self-evaluating, then we return exp, which is the expression itself. So you call eval on 5, you get 5. Right? Next case, it's a symbol, and we look it up. Okay? In this evaluator, which uses the substitution model of evaluation that you learned in Chapter 1, if eval sees a variable, it has to be a global variable, because it is something that was defined with a define form at the scheme prompt. Because anything that's an internal definition or that's a formal parameter of a procedure has been substituted out, right, by the time we call eval. Because remember back from Chapter 1, how do we call a procedure? We substitute actual argument values for the formal parameters in the body of the procedure. That gives us an expression that's just like the body of the procedure, but without any local variables. So the variables that we see mostly, almost entirely, are the names of primitive procedures. You know, you say cons, blah, blah, or you say plus, blah, blah. Those things are not self-evaluating. You know, the value of the word CONS is not the word CONS. It's the list, the pair constructor procedure, right? And the value of plus sign is not plus sign. It's the addition procedure, and so on. So in this evaluator, almost every time we see a variable, it's going to be the name of a primitive. Yes?
I was wondering, why do we need self-evaluating things, and why don't we just say everything's a variable, and some variables have a value which is the variable itself?
Okay, he's saying, why don't we eliminate the category of self-evaluating and just say 5 is a variable whose value happens to be 5? I guess that would make it harder rather than easier, because, you know, there are infinitely many numbers, right? And we're not really going to have a table someplace that says the value of 5 is 5. So what you're going to end up doing is making this same distinction inside your variable lookup procedure. And it's more obvious to put it out here. Okay? Okay, moving right along. There are 2 cases left. It's a special form. And this is the main thing that makes the real scheme evaluator in Scheme bigger than one screenful, which is that each special form has its own algorithm, its own rules for how it's evaluated. And therefore, each special form has a procedure to evaluate it. So when we look at the real thing in a few minutes, we're going to see things like eval if, eval lambda, you know, those things, right? For all of the special forms that we have, which is not going to be, by the way, all the special forms in Scheme. This is a subset of Scheme that we're interpreting right now. But each special form does its own thing. It takes the expression and does whatever it wants with it. And finally, if it isn't one of those things, then it has to be a procedure call. And on this line, and the line after it, oops, what did I just do? I said meta F. I meant to say control F. What? Okay, I'm confused. Oh, I'm in caps lock. What? Right? I'm in insert mode. Is that what you're saying? Oh. But kind of weird. No. All right. Okay. I'm not going to touch it. Okay, so this line right here and the line after it, this expression, are the heart of what we're learning from studying this evaluator today. It's not all. There's a lot of details that we're going to learn, but this is really the most essential piece of it, which is how do we evaluate a procedure call? So how do we evaluate a procedure call? Well, we evaluate all the sub-expressions, including the first one. It might be a lambda expression or something, so you have to evaluate it. And we apply, we use apply to call the procedure, which is the value of the first sub-expression, with the argument values that are the values of all the rest of the expressions. Okay? So apply, you'll remember from the calculator program, I hope, apply takes two arguments, a procedure and a list of actual argument values. Well, how we get the procedure is we eval the car of the procedure call, because car of the procedure call, its first element, is the sub-expression whose value is the procedure that we want, right? The sub-expression itself is, for example, maybe a symbol like plus sign or cons, or it might be a lambda expression, or it might be the call to some procedure that you wrote whose value is a procedure. But one way or another, the value of that first expression has to be a procedure. And then we take q52cs, which is the list of actual argument expressions, and we evaluate each of those by using map. We say map eval over q52cs. So what kind of recursion is this? Tree recursion, right? Because there's more than one recursive call to eval happening for each call to eval. Right? If we call a procedure with 3 arguments, we're going to do actually 4 recursive calls to eval. 1 for the procedure and 3 for the arguments. Okay? So we do that, and then we're in the world of apply. Remember, in the world of apply, there aren't any expressions. There's just values.